Hi, everybody. So, in Unit 6, we've done a couple of things. We spent a lot of time learning how to write formulas and name ionic compounds. And then we spent a little bit of time in the last class learning how to write formulas for molecular compounds and name molecular compounds. And I'm sure that what you're thinking right now is that's really easy stuff, and it really is. Naming and writing formulas for molecular compounds, especially, is very easy. The part that gets hard, especially for first year chemistry students, is writing formulas and naming formulas for both ionic and molecular compounds, because you have to follow different rules for those different kinds of compounds. So what I've done here, guys, is I put together a flow chart where you start with all chemical formulas, and then you distinguish between ionic compounds and molecular compounds. Okay? And you really have to go through this in your mind every time you're naming or writing formulas for ionic and molecular compounds. And I'm going to warn you, it can get a little bit frustrating, so you need to be patient and just it's going to come with practice, okay? So we're going to run through a couple examples right now, and then I'll have some homework for you. All right, I've just written a formula here. It's got sulfur and oxygen in it. All right, now we are going to follow this this flow chart in order to name this compound. And I know what you're probably saying. That's easy. It's just sulfur trioxide. And it is sulfur trioxide. But let's run through this flow chart to see if we're really right about this. So we start with the chemical formula, sulfur trioxide. And we look at this flow chart, we see that there are no metals in this compound. So here we are. It contains only nonmetals or metalloids. So we're just going to use the we're going to use the prefixes, the Greek prefixes that we learned about in the last class period. And we get the name sulfur trioxide. There's one sulfur, three oxygens. It's sulfur trioxide. All right, let's try another one. All right, here's another compound. I'd like you to take just a minute. I'd like to see if you can name this, and then let's run through the flow chart and see how you did. I'm just going to wait for a minute. All right, let's run through the flow chart and see what we come up with. Okay, so we've got this chemical formula. It's got aluminum and oxygen in it. Aluminum and oxygen. So aluminum is a metal. So we're on this side of the flow chart. Okay, aluminum is not a transition metal. It is actually a metal in the 3A column on the periodic table. So then we are just going to follow this rule here. The anion is oxygen, so it's oxide. So the name for this compound is aluminum oxide. So at this point, you might be thinking, wait a second, I don't understand, because here we had sulfur trioxide, and here now I just have aluminum oxide. I have two aluminums and three oxygens. Why is this not dialuminum trioxide? The reason is this. Okay, aluminum oxide is an ionic compound. There is only one way to bring together aluminum ions and oxygen ions. This is it. There is no other formula that it could possibly be. But on the other hand, with sulfur and oxygen, there's at least one other compound that I could think of, and that would be sulfur dioxide. Sulfur and oxygen can come together in many different ways. Aluminum and oxygen can only come together in one way. So why would we specify the number of elements of aluminum in this compound when it's not necessary. Why say dialuminum trioxide when there could only be one possible name for it, aluminum oxide? We have to specify with sulfur and oxygen, we have to say that there are 3 oxygens there, because in fact, if you weren't given that information, that could be 2 oxygens. That could be sulfur dioxide, okay? All right, let's try this compound. This compound has iron and oxygen in it. All right, if we go to our flow chart, we have a compound that has iron and oxygen in it. So the iron is a metal, and in fact, iron is a transition metal. Okay, so we're on this side of the flow chart. It's an ionic compound. Okay, we cannot call this di-iron trioxide. This is not a molecular compound. This compound is going to have this name. This is iron 3 oxide. Okay, so let's try this compound now. I'm going to pause for a minute. I'd like you to think about it. I'd like you to see if you can come up with the name. Follow the flow chart and see what you come up with. Okay, so let's follow the flow chart, all right? We've got a chemical formula. It's got phosphorus and chlorine. Phosphorus and chlorine, none of those elements are metals. So we're on this side of the flow chart now. Now we're going to use our Greek prefixes to name this compound. And hopefully you came up with phosphorus trichloride. Now, just to emphasize the point that this is a molecular compound and there are many ways that phosphorus and chlorine can come together, here is another compound that could be made with phosphorus and chlorine. If you read this formula, I think you will agree with me that we've got phosphorus pentachloride. If this was an ionic compound, there would only be one way that these elements could come together, and we would only have one name. But this is a molecular compound, and these elements can come together in many different ways. You could have 1 phosphorus and 3 chlorines, or 1 phosphorus and 5 chlorines. And this is why we have to specify, using these prefixes, what we've got in the formula. Okay.